An automobile gearbox, also known as the transmission, is a mechanical system that transmits power from the engine to the driving wheels while allowing the vehicle to operate efficiently under varying speeds and load conditions. Since an internal combustion engine works efficiently only within a limited speed range, the gearbox helps match engine speed with road speed to ensure smooth and economical driving. The primary function of a gearbox is to vary the torque and speed delivered to the wheels. When a vehicle starts from rest or climbs a slope, high torque at low speed is required, which is achieved through lower gear ratios. At higher vehicle speeds, the gearbox provides higher gear ratios that reduce engine speed while maintaining vehicle speed, improving fuel efficiency and reducing engine wear. The gearbox also enables reverse motion and allows the engine to run without stalling when the vehicle is stationary. A typical gearbox consists of an input shaft connected to the engine, an output shaft connected to the wheels, and a set of gears with different sizes mounted on shafts. In manual transmissions, synchronizers are used to match gear speeds before engagement, ensuring smooth and noise-free gear shifting. Power from the engine passes through the clutch or torque converter into the gearbox, where the selected gear ratio determines the output speed and torque. There are several types of automobile gearboxes used in modern vehicles. Manual transmissions require the driver to operate the clutch and gear lever to change gears, offering better control and simpler construction. Automatic transmissions shift gears automatically using a torque converter and hydraulic or electronic controls, providing greater driving comfort. Continuously variable transmissions use belts and pulleys instead of fixed gears, allowing seamless acceleration. Automated manual transmissions combine a manual gearbox with automatic shifting, while dual clutch transmissions use two clutches to achieve very fast and smooth gear changes. The gearbox plays a crucial role in overall vehicle performance and efficiency. By ensuring the engine operates within its optimal speed range, it improves fuel economy, enhances driving comfort, and increases the lifespan of engine components. Without a gearbox, modern automobiles would not be able to operate effectively across the wide range of speeds required in everyday driving. In a manual transmission vehicle, the gear stick and the clutch are two fundamental components that work together to control the movement, speed, and efficiency of the car. Unlike automatic vehicles, where gear changes happen automatically, manual vehicles require the driver to operate these components with skill and precision. Understanding their uses is essential not only for effective driving but also for ensuring the longevity of the vehicle. The gear stick, also known as the gear lever, is a lever that allows the driver to change gears in a manual transmission vehicle. It is mechanically connected to the gearbox and enables the driver to select the appropriate gear to match the driving conditions. By changing gears, the driver can control the amount of power transmitted from the engine to the wheels. For instance, lower gears such as first and second provide more torque, which is useful for starting the car from a standstill or climbing hills, while higher gears are used for cruising at higher speeds and improving fuel efficiency. Selecting the correct gear helps regulate engine power and allows the driver to respond to different driving conditions, such as overtaking another vehicle or maintaining a steady speed on highways. Efficient use of the gear stick also contributes to fuel economy, as driving in too high or too low a gear at inappropriate speeds can either waste fuel or strain the engine. Moreover, the gear stick plays a critical role in vehicle safety. Downshifting before corners or while slowing down can provide engine braking, reducing reliance on the brakes and enhancing control of the car. Additionally, the gear stick is used to engage reverse gear, which allows the vehicle to move backward, an essential function when parking or maneuvering in tight spaces. The clutch is a mechanical device situated between the engine and the gearbox. Its main purpose is to temporarily disconnect the engine from the wheels, allowing the driver to change gears without damaging the transmission. The clutch is operated by a pedal, which the driver presses to disengage the engine from the gearbox and releases to re-engage it gradually. This mechanism enables smooth starting, stopping, and gear changes. When starting the vehicle from a stationary position, the clutch allows the driver to release the pedal slowly while pressing the accelerator, preventing the car from jerking forward. Similarly, when coming to a stop, pressing the clutch ensures that the engine does not stall while the vehicle is stationary, which is particularly important in traffic situations. On slopes or uneven terrain, the clutch allows gradual engagement to prevent the car from rolling backward, and combining its use with the handbrake enables smooth and safe starts. Furthermore, correct operation of the clutch protects the engine and transmission from excessive wear. Improper use, such as sudden or incomplete engagement, can lead to engine stalling, grinding of gears, and damage to the gearbox, highlighting the importance of mastering clutch control for vehicle longevity. The gear stick and clutch are interdependent, and their proper coordination is crucial for smooth driving. Changing gears requires pressing the clutch to disconnect the engine from the transmission, moving the gear stick to the desired gear, and then gradually releasing the clutch while applying the accelerator. Starting on a slope involves pressing the clutch, selecting first gear, releasing the handbrake, and carefully releasing the clutch while accelerating to avoid rolling backward. When stopping or slowing down, pressing the clutch before braking prevents the engine from stalling. This coordination ensures that the vehicle operates efficiently, provides better control over speed and power, and reduces wear on mechanical components. The practical significance of using the gear stick and clutch correctly cannot be overstated. Efficient gear selection and clutch control contribute to better fuel economy and improved vehicle performance. Skillful operation reduces wear on the engine, gearbox, and clutch components, extending the life of the car. Smooth driving achieved through proper use of these components also enhances safety, minimizing the risk of skidding, stalling, or losing control, especially in challenging conditions such as wet roads or steep inclines. Furthermore, mastering the coordination between the gear stick and clutch develops the driver's overall skill and responsiveness, enabling them to handle a wide range of driving scenarios with confidence. The gear stick and clutch are indispensable components of a manual transmission vehicle. The gear stick allows the driver to control speed, power, and direction, while the clutch enables smooth engagement and disengagement of gears. Together, they enhance driving efficiency, safety, and comfort while protecting the mechanical health of the car. A proper understanding of these components and their skillful operation is essential for any driver seeking to drive efficiently, safely, and with full control over their vehicle. Automobile driving gears are a fundamental part of how a vehicle moves, accelerates, and operates efficiently under different driving conditions. A gear system allows the engine, which works best within a limited speed range, to power a vehicle that must operate at many different speeds. Without gears, a car would struggle to start from rest, climb hills, or travel smoothly at high speeds. Driving gears form part of the transmission system, which transfers engine power to the wheels in a controlled and useful manner. Driving gears are mechanical components with teeth that mesh together to transmit rotational force, also known as torque. They regulate how much power reaches the wheels and at what speed. The main purpose of gears is to adjust the relationship between engine speed and wheel speed. When the engine is running fast but the vehicle needs to move slowly, gears reduce speed while increasing torque. When the vehicle is moving fast, gears allow the wheels to rotate quickly while the engine runs at a comfortable and efficient speed. The number of gears in an automobile depends on the type and design of the transmission. Traditional manual transmission vehicles commonly have 4, 5, or 6 forward gears along with 1 reverse gear. Older vehicles often used 4-speed gearboxes, while modern cars typically have 5 or 6 speeds to improve performance and fuel efficiency. Some high-performance and sports cars even use 7-speed manual transmissions. Automatic transmission vehicles usually have more gears than manual ones. Older automatic cars commonly had 3 or 4 gears, while modern automatics may have 6, 8, 9, or even 10 gears. These additional gears help provide smoother acceleration and better fuel economy. Some vehicles use continuously variable transmissions, commonly known as CVTs. These systems do not have fixed gear steps like traditional transmissions. Instead, they use belts and pulleys to provide an infinite number of gear ratios. This allows the engine to operate at its most efficient speed at all times. Dual clutch transmissions, often found in sports and luxury cars, typically have 6 or 7 gears and use 2 clutches to enable extremely fast and smooth gear changes. Electric vehicles usually have a single-speed gearbox because electric motors can produce high torque over a wide range of speeds, reducing the need for multiple gears. Different gears vary mainly in their gear ratios, size, and function. The gear ratio determines how many times the engine rotates for each rotation of the wheels. Lower gears have higher gear ratios, meaning the engine turns many times for one wheel rotation, providing high torque but low speed. Higher gears have lower gear ratios, allowing the vehicle to move faster with less engine effort. The size and number of teeth on each gear also affect how power is transmitted, with larger gears generally producing more torque and smaller gears allowing higher speeds. Each driving gear has a specific role in vehicle operation. The first gear is designed to provide maximum torque and is used to start the vehicle from rest. It allows the car to overcome inertia and move forward, especially when carrying heavy loads or climbing steep hills. Because of its high torque and low speed, first gear is not suitable for fast driving. The second gear provides less torque than first gear but allows the vehicle to move faster. It is often used in slow-moving traffic, gentle turns, and gradual acceleration after starting. The third gear is commonly used for moderate speeds and is well suited for city driving. It offers a balance between torque and speed, allowing smooth movement without excessive engine strain. Fourth gear is used for higher speeds and more open roads. At this stage, the engine runs at a lower speed compared to earlier gears, resulting in quieter operation and improved efficiency. Fifth gear, often referred to as an overdrive gear, is designed mainly for fuel economy. It allows the vehicle to maintain high speeds on highways while keeping engine revolutions low, which reduces fuel consumption and engine wear. In vehicles equipped with a sixth gear, this gear further enhances fuel efficiency and driving comfort during long-distance travel. The engine operates at very low revolutions per minute while the vehicle maintains high speed, making the ride smoother and more economical. Reverse gear serves a unique function by allowing the vehicle to move backward. It works by reversing the direction of rotation through an additional gear mechanism and provides sufficient torque for controlled backward movement, such as during parking or maneuvering in tight spaces. Automatic transmissions manage gear changes without driver involvement. The transmission system uses hydraulic pressure, sensors, and electronic control units to determine the best gear based on speed, engine load, and driving conditions. Drivers simply select modes such as park, reverse, neutral, and drive, while the vehicle handles gear shifting automatically. Some automatic vehicles also offer manual or sport modes, allowing drivers limited control over gear selection when needed. Driving gears play a significant role in fuel efficiency. Using the correct gear ensures that the engine operates within its optimal speed range, reducing unnecessary fuel consumption. Lower gears consume more fuel because the engine works harder, while higher gears improve fuel economy by lowering engine speed. Modern vehicles are designed with advanced gear systems and intelligent control software to maximize efficiency and minimize emissions. Gears also contribute greatly to vehicle safety and control. Proper gear selection helps maintain stability when driving downhill through engine braking, reduces the risk of skidding on slippery roads, and ensures adequate power during overtaking or climbing hills. Incorrect use of gears can lead to engine damage, loss of control, or increased wear on vehicle components. In modern automobiles, transmission systems continue to evolve. Advanced automatic transmissions use adaptive technology to learn driver behavior and adjust gear changes accordingly. Hybrid vehicles combine traditional gear systems with electric motors, while electric vehicles simplify gear design due to the nature of electric power delivery. Despite these advancements, the fundamental purpose of driving gears remains unchanged. An automobile is a self-propelled vehicle used for transporting people and goods, and one of its most important systems is the transmission system. The transmission contains driving gears, which are responsible for transmitting power from the engine to the wheels. Driving gears help control the speed and torque of the vehicle so that it can operate efficiently under different driving conditions. The number of driving gears in an automobile is not the same for all vehicles, it depends mainly on the type of transmission used. Driving gears are essential because an engine cannot directly drive the wheels at all speeds efficiently. When a vehicle starts moving, it needs high torque and low speed, while at higher speeds it requires lower torque and greater efficiency. Gears allow the engine to work within its optimal speed range by adjusting the power delivered to the wheels. Without gears, smooth acceleration, climbing slopes, and fuel-efficient cruising would not be possible. In automobiles with manual transmission, the driver selects the gears manually using a gear lever and a clutch pedal. Older vehicles commonly had 4-speed gearboxes, but most modern manual cars are equipped with 5 or 6 forward gears. The first gear provides maximum torque to start the vehicle from rest, while higher gears are used as speed increases. A reverse gear is also provided to allow the vehicle to move backward. Therefore, a typical manual transmission automobile has 5 or 6 forward driving gears along with 1 reverse gear. Automatic transmission automobiles change gears automatically without the driver's direct involvement. These systems use hydraulic or electronic controls along with planetary gear sets. Earlier automatic cars commonly had 3 or 4 forward gears, but modern vehicles may have 6, 8, 9, or even 10 forward gears. The increased number of gears helps improve fuel efficiency, acceleration, and driving comfort. Like manual transmissions, automatic vehicles also include a reverse gear for backward movement. Some automobiles are equipped with a continuously variable transmission, commonly known as CVT. Unlike manual or automatic transmissions, a CVT does not have fixed gear steps. Instead, it uses a system of pulleys and a belt or chain to provide a continuous range of gear ratios. This allows the engine to operate at the most efficient speed at all times. As a result, CVT-equipped vehicles do not have a specific number of driving gears, but rather an infinite number of gear ratios, along with a reverse function. Dual-clutch transmissions are another modern type of transmission used in many performance and luxury vehicles. These systems use 2 separate clutches to allow very fast and smooth gear changes. Most dual-clutch transmissions have 6 or 7 forward gears, while some advanced versions may have 8 gears. A reverse gear is also included. Dual-clutch systems combine the efficiency of manual transmissions with the convenience of automatic shifting. Electric vehicles differ significantly from conventional automobiles in terms of gearing. Electric motors can produce high torque even at low speeds, which reduces the need for multiple gears. Most electric vehicles use a single-speed transmission with 1 forward gear and 1 reverse function. However, a few high-performance electric vehicles may use a 2-speed gearbox to improve efficiency at very high speeds. The number of driving gears in an automobile varies according to the type of transmission system used. Manual transmission vehicles generally have 5 or 6 forward gears, while automatic vehicles may have anywhere from 3 to 10 forward gears. CVT vehicles do not have fixed gears, and electric vehicles usually operate with just 1 or 2 gears. Driving gears play a crucial role in ensuring smooth operation, fuel efficiency, and overall performance of an automobile. Automobile reverse driving gears are an essential part of the vehicle transmission system, allowing the automobile to move backward when required. Reversing is necessary for parking, turning in confined spaces, and maneuvering in traffic or garages. Unlike forward gears, which transmit engine power in the same rotational direction, reverse gears are designed to change the direction of rotation of the drive wheels. This change is achieved through a specific arrangement of gears inside the gearbox, making the reverse gear unique in both design and operation. The basic working principle of the reverse driving gear is the reversal of rotational motion. In normal forward driving, power from the engine is transmitted through the clutch or torque converter to the gearbox and then to the differential and wheels. To obtain reverse motion, an additional gear known as an idler gear is introduced between the driving gear and the driven gear. When two gears mesh directly, they rotate in opposite directions. By inserting a third gear between them, the direction of rotation of the output shaft is reversed, causing the wheels to rotate backward and the vehicle to move in reverse. In manual transmission systems, the reverse gear mechanism is relatively simple and robust. The reverse idler gear is mounted on a separate shaft and is not in constant mesh like the forward gears. When the driver selects reverse gear, the gear lever moves the idler gear into position so that it meshes with both the input gear and the output gear. Once engaged, power flows through the idler gear, reversing the direction of rotation. Because reverse gear is generally engaged only when the vehicle is stationary, many manual transmissions do not use synchronizers for reverse gear, which can sometimes result in gear noise if engaged improperly. In modern manual transmissions, various design improvements have been introduced to enhance safety and smooth operation of reverse gear. Some vehicles are equipped with synchronized reverse gears, while others use mechanical or electronic interlock systems to prevent accidental engagement when the vehicle is moving forward. These systems reduce gear damage and improve driver safety. Additionally, the clutch must be fully disengaged before selecting reverse gear to avoid gear clash and ensure smooth engagement. Automatic transmissions achieve reverse motion in a different manner compared to manual gearboxes. Instead of using a simple idler gear, automatic transmissions rely on planetary gear sets combined with clutches and brake bands. Reverse gear operation is achieved by locking certain components of the planetary gear system, such as the sun gear or carrier, while allowing others to rotate. This controlled locking and releasing of components redirects torque flow and reverses the rotation of the output shaft. The process is managed hydraulically or electronically, allowing smooth and reliable engagement of reverse gear. The gear ratio of reverse gear is generally high, similar to that of first gear. This high gear reduction provides greater torque at low speeds, which is necessary for moving the vehicle backward from a stationary position or on an incline. For safety reasons, the maximum speed achievable in reverse gear is limited. This ensures better vehicle control and reduces the risk of accidents during reversing maneuvers. Reverse driving gears are also closely associated with various safety features in modern automobiles. When reverse gear is engaged, reverse lights are activated to warn pedestrians and other drivers. Many vehicles are equipped with reverse sensors, cameras, and audible warning systems to assist the driver. Electronic control units further enhance safety by restricting reverse gear engagement at higher speeds and preventing unintended operation. Despite its advantages, the reverse gear has certain limitations. In vehicles without synchronized reverse gears, improper engagement can cause noise or wear. Reverse gear mechanisms also add to the complexity of the transmission system. However, these limitations are outweighed by the essential function reverse gears provide in vehicle operation. Automobile reverse driving gears play a vital role in enabling backward movement by reversing the direction of power transmission. Whether implemented through an idler gear in manual transmissions or through planetary gear systems in automatic transmissions, reverse gears ensure controlled, safe, and efficient vehicle maneuverability. Understanding their construction and operation is fundamental in the study of automobile and mechanical engineering, as it demonstrates key principles of gear mechanics and power transmission. In conclusion, automobile driving gears are essential for controlling speed, torque, and efficiency. They enable vehicles to start smoothly, accelerate effectively, cruise economically, and operate safely under diverse conditions. Whether in a manual, automatic, hybrid, or electric vehicle, driving gears remain a core element of automotive engineering and play a vital role in everyday transportation. Thank you for watching this video.